Hello everyone, welcome back to Dev Days Europe after the break. I'm Christina, your host on stage 6, and we continue with very interesting talk. Eyal Keren, who is going to introduce us to Wing, a programming language for the cloud. Eyal is the Chief Product Officer for WingLang. He has prior experience as CTO and co-founder of Rollout.io, which was later acquired by CloudBees. And today he will demonstrate us with a whole new programming language. Eyal, why do we need a new programming language for the cloud?
Thank you very much, Athena. It's an excellent question. Why do we need the programming language for the cloud? And I will hope to answer this. But in a nutshell, I want to say that the developer experience for building cloud application right now has degraded. And the reality is that it's very hard to write cloud application and enjoy doing this, being inside the flow. So that's what I'm going to introduce basically right now. But before I start about the programming language for the cloud and why do we need it, who we are even. We are Monada. We're the company behind WingLang. We were founded in kind of a year ago by Shai Ber and Elad Ben Israel. Elad Ben Israel is the creator of the AWS CDK, the Cloud Development Kit. And in a way, WingLang is yet another open source project, as well as the CDK. In a way, Wing is basically an evolution of the CDK. Wing was released in alpha back in December, and we plan to release beta this year. And we have a community starting, and I'm hoping that people kind of viewing us will be able to join this community. So back to your question, why do we need another programming language, and what's different with Wing? I'm going to start with a really, really simple example, not using Wing, using JavaScript and Terraform of a very, very kind of rudimental cloud application. So this is my state-of-the-art cloud application. It has an SQS queue and a Lambda function. I'm using the AWS taxonomy, but this could be a RabbitMQ and a pod. This could be a Fargate. This could go into Azure, Google, AWS. I'm just using the taxonomy just not to have another level of indirection. So, and the application that we're going to build is basically, I'm not going to build it, I'm just going to present it. It's basically how to process a message from the queue into a Lambda function. And what do you have to do? So the first thing, I'm going to present the Lambda code that goes inside the Lambda. So this is example_lambda.js. It's a JavaScript file. This has nothing to do with Wing yet. And this is basically the code that you need to do. It doesn't do anything in order to process the JavaScript code that you need to do in order to basically to be hosted. The Lambda is going to run this code when a new event arrives to that Lambda from the queue. The second thing is we have to provision stuff. So we saw here we have the SQS queue, we have the Lambda function, and we have that connection here. So we have to provision those three things. So let's go into provisioning this. The first thing is the Lambda Terraform file. This is a Terraform file. And we see that we have a resource here, the AWS Lambda function. It has a name. It has the example Lambda handler that we've seen before. And you also have a reference to the actual data archive file, which is a zip file, which part of your CI process, the code that we've seen before, you have to basically kind of build that, bundle this thing, and build this and put this in a zip file and put this on a bucket. There's some work that has to be done. But eventually, when you do Terraform apply for this code, it will provision a new Lambda function. So we have a Lambda function. Next thing is let's take a look at the SQS. This is the Terraform file for the SQS, very, very simple. I'm going to move forward. And the last one is, not the last one, and the next one is the AWS Lambda event source mapping. So it's an event source mapping. The source is the queue, the destination is the example, and this is basically the error between those two. We have to provision those three resources. Now in a perfect world where we don't have hackers, we don't have to worry about security, this would be enough. But by definition, by default, resources are not provided with any permission to do anything, so we need to give distinct permission. Now, this is where I am as a developer. I usually kind of doze off and kind of leave the room, but I'm going to look at this anyhow. We have a Terraform file, which has a bunch of resources. Just as an example, in order for the Lambda function to be able to access that SQS queue, it needs to get the following permissions. It needs to change the message visibility, it needs to delete the message, it needs to know about that queue, and it needs to receive this message. Now, this is just one resource out of about 4 resources that we're seeing in the IAM here. As you can see, I've folded things up. There's a lot of code here. I'm not going to show all of it. Now, why am I telling you this? The reality is that even that simple application is not that simple. We had to create 7 resources in order to run this, in order to deploy and run this flow. And we had to know how to package stuff, and we have to understand what are the specific permissions that a Lambda function needs for a queue. And all of this is basically kind of, it's part of the DevOps engineering, basically kind of professional, but they have to really know the intimacy of their designated target cloud. And the reality is that we believe that the problem that we have right now is that JavaScript or any other language is a programming language built for a computer, while Wing is a programming language built for the cloud. So this is an important distinction, and I'm going to talk about distinction in a second. So what is the difference between a programming language built for the cloud and programming language built for a computer? So let's take example C. Definitely a programming language built for a computer, runs on a VM. So C targets computers. When I run C code, when I write C code, I run it kind of agnostic to the actual instruction set or target operating system. But when I compile it, I can give it compilation arguments to basically say, compile this to x86 or ARM on Linux or Windows. C includes a standard library that gives me abstractions for things like files. I don't care whether the file system is RazorFS, NTFS, FAT32. I don't care what kind of file system. I know I want to open a file, read a file. I have those things. I have malloc, I have mutex. I don't care whether this is big Indian or small Indian. All of this gets abstracted away from me by the standard library. And another interesting thing about programming language that target computers as their operating system is that anything under the same application in C has the same memory and runtime space. Of course, you can fork, but let's not touch that in a second. Let's jump to Wing and see those kind of 4 things, how they compute into a cloud-oriented programming language. So Wing target clouds, which basically can be kind of seen as a distributed computer. Instead of being compiled into assembly of that specific computer like C does, Wing needs to compile to the assembly of the cloud. What is the assembly of the cloud? Just a second ago, we saw that if I target AWS and Terraform, I have Terraform here and JavaScript. It can also be Terraform and Docker. It could be CloudFormation and Docker images. It could even be Kubernetes. So it could be, if you're deploying into a Kubernetes cluster, your cloud could be Helm charts or any YAML files. The standard libraries that are required from a programming language that targets the cloud is different. Instead of having a file and a mutex and some memory, we have queues, we have buckets, we have API gateway, we have databases. These are kind of the primitives that the cloud has. And all the cloud, if I want to have a queue, probably all your systems, all your cloud applications have a queue, whether it's a RabbitMQ queue, an SQS queue, a Google PubSub, anything, you probably have a queue in your system and a bucket, whether it's using Mini.io or S3. And the last one is it has to be distributed by design. So this is versus the single runtime, single memory. In the cloud, things are running in a distributed manner, in different runtimes, running by different services, by a Lambda function, by Fargate, by pod, auto-scaling groups of a Kubernetes cluster. So it has to be different. So let's again start simple and see how, using Wing this time, we are processing a message from the queue in Lambda. So again, SQS and a Lambda. Wing doesn't know about SQS and Lambda, so we're gonna see a queue, and we're gonna see this in a second. So this is the first time you've seen source code in Wing. I'm using VS Code. I'm doing first.w. W is the suffix for Wing. And the first word you're seeing here is bring cloud. Bring is our import statement. So instead of import, we're using bring. Bring cloud. Cloud is our cloud standard library. And line 2, we're seeing let queue equal new cloud queue. This is how I provision a queue, okay? And then I'm doing queue.add consumer, and I give it an in-flight function. And inside that in-flight function, I write the code that will run inside that in-flight function. Now, the first thing that comes to mind when you're seeing this code is that infrastructure as code in Wing is in the same language, as you can see. Of course, you could use different files. You don't have to put everything in the same file, but it's in the same language. What do I mean? Let's take a look at the code here. This in-flight code is basically what we've seen as the example JavaScript, example lambda.js file. And interesting enough, this will compile into a JavaScript file. So this thing runs in the cloud. So once I deploy my application, once a queue will get a message, this code, there's going to be a Lambda function or a Fargate or anything else that will basically trigger this code. The other part of this code here that is not highlighted is the pre-flight code. We call it pre-flight code. And this code that basically is the provisioning code. So creating a new queue and hooking up the queue to a consumer, and that function basically will automatically also generate a Lambda function. So there's two things here. There's pre-flight and in-flight. In-flight. It runs on the cloud. It's basically we're either building Docker images, or we're building Lambda archive zip files, or to any other designated clouds. And that's what Wing does. It just preps it for the cloud to run it, because Wing doesn't runs the cloud. The cloud runs on AWS, on your cloud, whatever you want. The second thing, that the in-flight code is compiled to JavaScript or Docker images. And the last thing is kind of weird. I want to show it with the editor, is that when I'm interacting with a resource, with a bucket, with a queue, inside in-flight, I'm accessing that client API. So when you think about the queue, I can push, I can purge, I can pop, I can do things that you can do with a queue in runtime. But when I work in pre-flight, I can provision it, I can add consumers, I basically set up kind of the stuff that you will do in Terraform or in CloudFormation. The pre-flight code is the other side of this. It runs during deployment. So Wing compiles pre-flight code into Terraform and any other language. And the pre-flight code runs when I actually deploy the code. And when I interact with the resources, I actually have the provisioning API. I'm not sure if all of this makes sense, but maybe writing code will help. So as you see, let me make this a little bit bigger, maybe not that big. And let's do this. So what do I have here? I have the same code that we just seen in the example. I have the bring cloud. I just didn't call it app first. I call it app.w. I thought it would be a better name. And I have the bring cloud. I have a queue. I'm creating the queue. And I'm doing queue.add consumer, the same thing that we saw. And now I'm going to use the Wing command line. I'm going to do Wing. Sorry. I'm going to use the Wing command line, and I'm basically going to do Wing compile the app.w, and the target will be tf-aws. So Terraform for AWS. I'm going to compile this. Once this is done, I can see that in the target directory, I have tf.aws target, and I have a main ts.json. If I look at this file, let me get this let's get this. I can see all the things that we saw before when we were basically building kind of the JavaScript, when we were going through the JavaScript and Terraform. So I can see that I have an IAM role for the consumer, and I see that I have the policy to bring this information. I have the event source mapping that we saw before, which with the batch size. We have the Lambda function and some other stuff. The bucket is for actually storing the code. There's some other stuff here. Also, we should be seeing the SQS. And we also have the SQS here. So all the things that we saw before is now a compilation asset of Wing. Wing doesn't take responsibility to actually deploy your cloud, but it outputs something, in this example, Terraform. The other thing we have here is we have the archive zip file. I'm not going to open it. It's the same JavaScript code that you saw before. It's automatically generated. And the important thing about this is that Wing doesn't change any downstream tools. If you're using Chekhov or TFSec for checking your Terraform, you can still do this. If you're using Dependentbox for your NPM, you can still do this because the kind of the downstream tools are compatible with JavaScript and Terraform. Now I have a to-do list here. Now I want to add a bucket to show you how things work. But before I do this, I want to show you another thing that Wing allows you to do. And back to the question that I was asked, why do we need a new programming language? The answer is to actually get a better developer experience, a much better developer experience. So I'm going to do Wing run, and I'm going to give the app.w file. It's going to open a console. I'm going to move it to the side. I don't know why it opens it so big, but that's the way it is. Okay. And this is a localhost implementation of the cloud. So we have a bunch of implementation of the cloud. We have the AWS implementation, the Azure, the GCP, we have Kubernetes, and we also have a localhost implementation of the cloud. And this implementation of the cloud allows me to interact with stuff. So if I go into this queue, this is the queue here, click on it, I can just push a message. Hi. So hello, Wing. Let me push this message, and I can see the log that was here. I can see it over here. Let me get this a little bit bigger. Great. So I've pushed the message. Now I want to add stuff. So let me do let b equal new cloud bucket. Okay. Once I save this, the console on the right side will automatically be updated with the cloud bucket. As you can see, the cloud bucket is not doing anything. No one is using it, right? I can interact with it, but there's no point to it. And now I'm going to go inside the in-flight code. Let me get this a little bit down. And I'm going to do put, you know what, let me b dot. You can see that I have the API of a bucket, what you would expect from a bucket, to put objects, to get objects, basically kind of create files, get files. This is a file. This is what you expect in-flight of a bucket. And I'm going to do put, I say last.txt, I'm going to store the last message. So a lot of message is going to be stored here, but the last message is going to be used here. And I'm actually, just to show you the other side of b dot, I'm going to do b dot here, trigger the IntelliSense here, and I see that I have a different API for the bucket. I can't push things when I'm in pre-flight because this is not the API of a bucket. But I can do onCreate function. I can say in-flight, file. By the way, as you can see, the language is, we've built the language to be familiar to people who are using TypeScript, Java, all those familiar languages. And I'm going to do log file was created with, and let's just give it a name. Great. So now we have this thing here. We have we can see that we have an onCreate event that basically triggers something. And I'm going to go to the queue, and I'm going to push a message. Once the message is pushed, the add consumer will trigger this log, and will put last.txt with this message. And then this thing, the onCreate, will also be triggered. File was created with a name. Let's do this. File, for it to read better. Okay, great. So I'm sending a queue. So hello, Wing 2. Send this. Now I see that the message was created, file last text was created. We're seeing all those things. And now let's go into the bucket and see that in this bucket I have a file. I can download the file, but I can also see this. I'm not sure if you're able to see this. Let me get this trigger. We're able to see the actual content of the file, hello Wing 2. And I can actually download this file, or I can upload another file. If I upload a file, the onCreate will be called. So I'm just going to open app.w, and I see file app.w was created over here, as you can see. Great, let's clear this thing. Let's do this thing here. So now what I've showed you, kind of to sum up, we were able to create a bucket. I haven't shown you that actually this bucket is provisioned. So I'm going to build this for AWS for a second. We were able to create a bucket, and we'll be able to interact with this bucket in flight and pre-flight. So let's see this bucket here. Now to look for this bucket, I'm going to look for put object. And the reason I'm looking for put object is because I want to show you that automatically the compiler put object. Automatically the compiler has gave only the required permissions for the lambda function to be used. So let's go over here. The compiler sees that this lambda function here, the add consumer lambda function, goes and interact with b.put in runtime. So it gives that specific function only the kind of the least privileged permission for that bucket. So automatically we have least privileged permission as part of the flow. Okay, so we have a bucket. I want to show you something interesting and write a test. So the nice thing about when you're building a programming language that is doesn't care whether it's deployed on any cloud, it's agnostic to the cloud, you can write tests that test my bucket that actually runs the same on all the clouds. So I'm going to use the bucket that I already have. I'm going to put a file. I call it file.txt, and I'm going to say hello, or let's say data. Then I'm going to do assert data. I'm going to have an error here, just because I like to see my test fails. I'm going to do b.get file.txt. And of course, I forgot this thing. And let's do wing test app.w. And this will automatically, the test is going to fail. I'm going to clean it. This will automatically run the test. Sorry. 8, okay. This will automatically run the test and the test passes. File text was created. I can also go and run the same test, and this is revolutionary in my point of view, into the TF AWS target. Now, if I go through this, it's going to compile the TF AWS. It's going to do Terraform init as the next step, and then it's going to do Terraform apply and run the test, and I'm going to see the same result. I'm not going to wait for this because Terraform apply can take some time, so I'm going to break this for a second. But the idea behind this, let me just open another. We can visit this later. And the idea behind this is you can write the same test. This could be an acceptance test, the same test, and run them across your multiple clouds. Great. So we wrote a wing test and we run it on both things. Let's use Redis instead of a bucket. So let me close this thing. You know what? Let me actually show you something. I have Docker running on my system, as you can see. And I'm going to do bring Redis. Now, what this is not bring cloud, it's something experimental that we're working on. And I want to show you this because you can basically, because this is an open source project and it has an open ecosystem, anyone can just create any NPM package that implements any resource across different clouds or across even one cloud. But the nice thing to do is to give me a resource that is running both on the simulator, on the localhost, and on a specific cloud. And we can use it. So let me show you how it's done. Let's do let db equal a new redis.redis. Now, as you've seen, I did Docker PS before. Let me delete this bucket and also delete this bucket. I see Docker PS before. Okay, I still have this test. Let's remove this test. Great. And now if I'm going to do, okay, now let me save this. It will automatically save it. And behind the scenes, the localhost implementation of Docker, of Redis, is to set up a Docker image of Redis running on my machine. The Terraform, we're going to take a look at an example on the cloud implementation in a second. And what I'm going to do here, I'm going to basically use Redis. So I'm going to do DB. And the Redis API, if you don't know, has something that's called sadd, which is basically kind of a set. I'm going to call it messages. I'm just going to call it, okay, messages. And I'm going to give it the message. So this command will basically just create a set inside Redis and basically will push that message here. I can go here to the Redis, to the console into the Redis resource. And I can actually have a command line here that allows me to interact with this Redis. So I'm going to do s members for messages, and I'm going to see what's s mem. Okay, so I'm going to do s members for messages. And see, I don't have anything here. I'm going to save this because this is, as you can see, it's hard for me to write this. And I'm going to push a message number 1, send this, and message number 2, and the number 42, the favorite number. And now I'm going to go inside the Redis, and I'm going to go and I'm going to look at messages. Now I see I have 42, message number 2, and message number 1. So what we've seen is that I can actually write some code, and now those messages are stored inside Redis. Why would I want to do this? I don't know, but it's possible. If that's what you want to do, you can store all your queue in Redis. And just as the other side of things, we can do a Wing compile tf AWS, the same app. And now, if we look at this file, if we look for Redis, we're going to find that we have an Elastic Cache subnet group. And it has a Redis cluster running inside of it. Let's see if I have another one. This is the subnet group. I'm looking for the cluster. Let's look for cluster. Yeah, great. So I have a Redis cluster automatically generated. I can deploy this. It takes some time. The interesting thing about this is that the Redis on the local host is basically a container running the Redis. And on AWS, it's going to be Elastic Cache cluster. And the Elastic Cache cluster comes with a lot of restrictions. It has to run on the VPC. So basically, the person who wrote that specific Redis resource had to do a lot of work in order for this to work out of the box inside the VPC. By the way, it's important to note that all the output, this is the output that comes out of the box for free, you can alter, you can modify the output, and basically there's no, we basically, the Wing language basically gives you an out-of-the-box experience, but you can change, if you don't want that Lambda function to be a Lambda function, you want it to be a Fargate, inside AWS, you can do this. If you want every bucket to be duplicated across multiple regions, and you can do this. Everything is possible with something we call Wing plugin. So coming back to this example, I've showed how to instantiate a Redis and edit consumer. What's next on my to-do list? Okay, so I've done this. Oh, the next one is extern.js. So hopefully I have more time. So what I wanted to do is show you that we can use JavaScript. I mean, Wing, because this is a new language, Wing is, although it's a new language, we didn't want to start a new ecosystem, basically. And because Wing compiles into JavaScript, we thought it would be very pragmatic to allow you to add JavaScript code. So I'm going to do class JavaScript helper, and I'm going to do extern helper.js. And I'm going to do in-flight function. I will call the function foo that will return a string. Okay. And I'm going to click and create this file. I'm going to do exports foo equal, let's get this thing out, function that doesn't accept anything, and say return I am from JS. Wait. And let's instantiate this thing. Let's do let JS equal new JS helper. And let's do was received. And let's replace this message with you know what? Let's save inside. No, let's do let's just log JS foo. So if you're using Axios, if you're using anything you want to use inside the JavaScript ecosystem, you can just basically import this. And as you can see, I am from JS, this code here. So I can actually do, I can use anything that, I can just import anything I want and just require it, and just an npm install here. And the language itself comes packed with kind of like Java had JNI, Java to native for running C back in the day. So Wing also comes supported with all the goodies and the vast ecosystem that the JavaScript TypeScript system have. Great, so I've done this to do. Now I'm going to add an API gateway. Maybe the last thing I'm going to do. Now I'm going to cheat. I have some cheating code here. And I'm going to have this API gateway here. Let's see what it does. I go to the API. I create a new cloud API. This is interesting because on the client side, this will be running Express. So on my local host, this will be running Express. Whether if people know Node.js, Express is basically a web framework, a web framework for web applications. And when I deploy this to AWS, it will run out of the box. It will use AWS API gateway. So what did I do here? I said API.get when someone calls messages. Let me see that I've used it. Okay. When someone calls messages, call that in-flight request response API and return DB S members messages. I'm going to save this. Great. And I'm going to go, let's get this a little bit bigger so we can see what's going on here. So I have this API, I have the JS helper, I have all those things that I created, the Redis. I have nothing in the Redis right now. I can go to the API, and in the API, I can just, I'm using kind of a split screen, so it's kind of hard. I can just go and just, what am I supposed to do? What? Okay, messages. And I can just hit this API. If I just do like this, it's not going to work because I cannot get this. But if I do messages, I have an empty messages. Okay, so let's add messages. The way to add messages right now is going to the queue and send a message. M1, send. M2, send. M3, send. Now, when I'm going to hit this API gateway, let's go to the S members and output the messages. So let's refresh this. And now I have all those things. So pretty cool. Pretty cool. That's what I'm thinking. I don't know whether you're excited or not, but I'm completely excited about this. So I think I kind of went through all the things I wanted to show. The API gateway, the bucket, the Redis. I mean, I showed you how to do Docker, running tests, and also kind of running them on remote. Let's go back to the next step here. So what's next for us? What's next for you? Hopefully, you would go and visit Winglang.io to get involved, to bring yourself, to get our feedback, both good feedback or bad feedback. There's a lot of things that we can learn with. It's very open. You can join our Slack. You can email me or connect to me on Twitter. That's basically it. That's the entire conversation.
Thank you so much, Eyal. And that was it was exciting for me, even though I'm not a cloud developer, but definitely it was exciting. I want to ask you, what's your long-term goal? What mission are you with that project?
Yeah, that's a good. So the mission for Wing is basically to democratize the cloud, to allow developers to build cloud applications in ways that adhere to the enterprise concern. It's very important that you have both those sides to allow a developer to go to write software, but then the enterprise, I mean, on any kind of out-of-the-box software that Wing is going to generate is not going to be applicable to the enterprise because there's SOC 2, there's HIPAA compliance, there's a lot of things. So the thing for Wing is to have those two legs. One, a self-service, nice, fun experience that allows you to be in the flow when you're writing code, and then all the customization that is required by the DevOps people, but not be in each other's way. Decide on the architecture together, but then everybody can work on its own and they're not being blocked. Think about what's happening today. When I'm writing software for the cloud, I can't even run it locally without a DevOps. I can't compile it without a DevOps to help me. I need to know so much about the intimacy of the cloud, the assembler of the cloud, in order to do this. We want to take away that we want to basically streamline the process of development, but allow enterprise to work in a secure way.
That's very brave mission. I need to thank you for that wonderful presentation. Some might say it was technical, it was eye-opening, there were really revolutionary things you showed us here. You showed us how you can just test it. You showed us how you could just run it to any target you want. Thank you so much for this talk, and good luck with the project.
Thank you very much, and thank for the opportunity to have this talk. Bye.
Thank you. Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, buddy, I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's stars. We